Okay, today we're going to look at calculating the equilibrium constant given initial concentrations and concentrations of at least one reactant or one product at equilibrium. Okay, so the first thing we need to do is fill out the ICE table. Sometimes you'll see these called RICE tables, um, whereas the R is the reaction. And then you have the initial, the change, and then the end in equilibrium. So the reaction, we have two reactants. We have CO, we have H2, and we have CH3OH. And this is not balanced, but to balance it, one C, one O, we need a 2 right here. So I like to put that on my rice column as well, just it helps me remember. Um, so initial, it says that a reaction mixture initially contains 0.5 moles of CO, so 0.5 moles, and 1 mole of H2. And I'm changing my color just because the 5 was a little hard to read. And then, of course, at the initial, we have no products. So the change, this one will go up by 1, so it's going to go up by plus x. This one will go up by plus 2x. I'm sorry, these go down. Minus x, minus 2x, and plus x. And then it says at equilibrium, the CO concentration is found to be 0.15. So 0 minus x equals 0.15. So that means x has to equal 0.35, which means that over here 2x will be 0.7. And x again is 0.35. So the final concentration of CO was given to us to be 0.15. The final concentration of H2 is going to be 0.3 moles. And over here, we're going to have 0.35 moles. So now what we need to do is we need to set up our formula. So K of C, we'll go back to the yellow, or light, yeah, let's go back to the yellow. K of C is equal to concentration of CH3OH at equilibrium divided by the concentration of CO and the concentration of H2 to the second. So now when we fill in those answers, we wind up, or those unknowns, we have 0.35. divided by 0.15 and 0.3 squared. And our answer will be 26. Okay, so let's set this one up. Starting with setting up the reactants and the products, we have 2 methanes, and it is yielding 1 C2H2 and 3 hydrogen gases. We know that these 2 are products, so they initially start at 0. And then as we read our question, it says that it initially contains 0.115 moles of methane. And then at equilibrium, the mixture contains C2H2 of 0.035. We know the change. The methane is going to go down by 2x. We know that the C2H2 is going to go up because it is a product, so it is going to go up by x. And we know that hydrogen is going to go up, again because it's a product, by 3x. So if we look at the C2H2, 0 plus 1x equals 0.035. So we know that x has to equal 0.035. So 2x, 2 times 0.035 is going to equal 0.070. And 3 times 0.035 is going to equal 1.105. So our ending concentration at equilibrium for methane is going to be 0.040. And for the hydrogen gas, it's going to be 0.105. So now to determine that concentration, we need to set the expression. Kc is going to be equal to the concentration of H2. Let's look at C2H2 first times the concentration of H2 cubed, because there was the coefficient of 3 for H2, divided by the concentration of methane, and it is squared. So now if we plug these numbers in, we wind up with 0.035 times 0.1105 cubed times 0.035 squared, which when it's plugged into the calculator is 0.020. And remember, there are no units on our equilibrium constants. Okay, why don't you go ahead and try this one? And when you're finished, that should be the next slide on the Nearpod. Thank you.